And it's $3. Registration ends on Wednesday, September 9th. There are no exceptions to that. So let's say you're driving to school on Wednesday, September 9th, and I don't know, somebody rear ends you and you end up missing school that day. Don't come to me on September 10th and try to register. The moral of the story is don't wait till the 9th. Get it done ahead of time to make sure that you get in. I emailed you all the order forms for the t-shirts and the sweatshirts. All the cool kids will be wearing those, so you'll want to be sure to get yourself one. All right? Okay. Who had a question either in the book or on your review sheet about one of the homework problems? Anybody find something? Caitlin.
I need to double check, but I think it's 15.
15 says we want to show that we have a right triangle. And they give me some points that are going to make a triangle. Right?
Yes.
Now, I need to show this as a right triangle. Somebody this morning said it looks like it. That is not a good enough reason.
Do we have to have two the same distance?
To be a right triangle, do I need two the same distance to be a right triangle?
No.
Now, what would that be? Isosceles triangle. So if it said show it's an isosceles triangle, then that would be what we do. We do our distance formula and show that two of them match. That's not what it says. What do we do? Brooklyn.
Shouldn't you just find the distance, like in between two of the lines or whatever, and then try to do the Pythagorean theorem?
All right, that's one option. That's a really good option. She said, if this is a right triangle, then the Pythagorean theorem has to work. Correct? So she said, if I find all three distances, and I'm not going to do that, but if I found all three distances, and let's say one of them was root 11, and one of them was root 12, and the other one was root 23, then I would know I had a right triangle, because this squared plus this squared equals this squared. So that would tell me I had a right triangle. I would need all three distances. What's another strategy, Jim?
Find the slope of them and see which slopes are perpendicular.
Exactly. So another way, and maybe faster, this is perfect. This is beautiful. Absolutely nothing wrong with it. But it might be faster, especially since I can look at my picture. This looks like it might be the right angle. So I'm going to try this slope and this slope and see if they are opposite reciprocals. And that would do the trick too. Either way is fine. So remember how to find slope, 11 minus 1 over 3 minus negative 2. So that slope is 2. So this one, if these two are the perpendicular sides, then what's the slope going to have to be? Negative 1/2. So 11 minus 9, 3 minus 7, 2 over negative 4. Got it. So how do we know it's a right triangle? Two sides are perpendicular, or two sides have opposite reciprocal slopes. Okay? All right, who else found one that you had a question about? Brooklyn?
For number 1, I was just confused with the bounded, like what that means.
Okay, bounded means that your endpoints are included. So the only way you can be bounded in an interval situation is if you have brackets on both ends.
Or maybe unbounded if it's...
Otherwise, it's unbounded.
And then how would you write... So did it just want us to write it out with the inequality sign? Because they gave us like 0 and 5 brackets.
I think they wanted you to find endpoints. They wanted you to, I think, just kind of like draw it. So your endpoints would be at 0 and 5.
Okay.
I think that's all you had to do.
Okay.
All right, who else? Anybody else have a question about that? Yes, Caitlin.
For number 5, would you have to times the bottom by, like the whole thing by the negative to get it to
Okay, on which problem?
number 5?
I don't see a negative in there.
Well, never mind.
Did you see a negative?
No.
Well, tell me what you mean. I don't understand what you mean.
Because it says the denominators are not 0. So would you have to?
Oh, no. Okay, let's just simplify this. So these cancel, so I just end up with even 4th. That's all that's left anyway. But what they mean is, they're just trying to cover all their bases. When you build a fraction, can the denominator ever be 0? These are variables. So they're just telling you, assume that none of your variables is 0.
Okay.
Which we haven't even, that hasn't even been on our radar, but they're just trying to be very precise. Don't worry about zeros.
Number 22.
The distance between z and negative 3 is less than or equal to 1. All right, this goes back to the number line. How do I find the distance between those two numbers on the number line? Subtract. Distance is a difference. It's a subtraction. Right? The two things that I'm finding the distance between 8 and 12 or 12 and 8, I can do it in either order. Right? As long as I take the absolute value. So this says the distance between z and negative 3. Now, this is how you did the distance between 8 and 12. So how are you going to do the distance between z and negative 3? Z minus negative 3. Right? Or could it be negative 3 minus z? Yeah, but I like to have my variable first. And that has to be less than or equal to 1. And I'll change that to a plus, and I'm all done. Jack?
Is number 21 like that first one you did before?
21. Yep, it's exactly that. They're just telling you you have to use the Pythagorean theorem. So you're going to find the length of each side using your distance formula, and then you got to square 2 of them to add up to be the other one squared.
So it's a double negative.
Can I double check with 53?
First of all, I'm impressed as heck you made it all the way to 53. Oh, aren't you amazing? 2x squared minus 3x minus 1. Now, I am not going to do this to you. I am not going to tell you that you have to complete the square on a problem like this. I'm not saying I won't tell you have to complete the square. But what's the issue with completing the square on this one? We're going to, well, having the coefficient isn't the problem. The problem is when I divide, I end up with a fraction. And then I have to take half of the fraction and square it. I end up with more fractions. And then it becomes an arithmetic problem, not a completing the square problem. But let's do it. We'll do it. We can handle it. We're big kids. We can do it. So I divide everything by 2 and move the 1/2 to the other side. Now, I need to take half of 3/2. What is half of 3/2? 3/4. And then I have to square it, so I get 9/16. So I am going to add 9/16 to both sides. This needs to be a perfect square. What perfect square is it? X minus, not 3/2.
1/2.
3/4. Remember, this gives you the x, this gives you the 3/4, and then you got that minus right there. And that equals, okay, get a common denominator, 17/16. What happens now? Square root both sides. Kids, you need to be comfortable with the process, right? The fractions, don't get all bogged down in the fractions. You need to know what the process is. You're going to take the square root of both sides. And on this side, you have to remember plus or minus the square root of 17/4. Because when I have the square root of a fraction, it's the square root of the top over the square root of the bottom. And then I'll add 3/4. Now that's perfectly okay, but since they have the same denominator, I could put them together, which is the way it would look if you'd done the quadratic formula. This is how it would have come out. Okay, so again, I'm not going to fill your problem up with fractions, but you have to be able to complete the square. You need to know the process. Will?
On the second to last step, could you just multiply everything by 4 and have 4x so you don't have to worry about this 4?
The problem is, your job is to solve for x, not for 4x. So, I mean, you could do that, but you're just going to end up dividing it out again because you have to have x by itself. Yeah, we can't get rid of the fractions because we need to have x solved for. All right, anybody else on the worksheet or the book? Yes, Caroline.
For the book, just double checking 22.
I did 22 right here.
Oh, okay. Sorry.
It's all right. Anybody else? Worksheet or book? Caitlin?
Number 26 in the book.
-5, 4, and 2, -5. And we're going to write the equation of line. So Caitlin, what do we do when we write the equation of a line?
You have to find slope first.
Yep. So this is lovely, -9/7. Okay,
And
now
then
what?
You have to plug it in. So then I usually do like point slope.
Okay, so y minus 4 equals -9/7 x plus 5. Is that all right?
Yeah.
So y minus 4 equals -9/7 x minus 45/7. Now, normally I would add 4 to both sides, get a common denominator and add, but these directions, for whatever reason, stipulate that the line needs to be in standard form or general form, which means the equation has to end up looking like this, or like this. Depends which book you look at, whether they want it equal to 0 or not. So that's what I want my equation to look like. So in other words, I'm not to get y by itself.
Okay.
So I'm going to multiply everything by 7, because in this case, it doesn't matter what my coefficients are. So I'm going to go ahead and get rid of those fractions now, and then move everything over to the same side. So 9x plus 7y plus 17, if I've done my arithmetic right. And that would be the standard or the general form of the equation.
Okay.
Procedurally, you do everything you always do. It's just a matter of how you write your final answer. All right, anybody else have a question from the book or the review sheet? All right, then you can have the rest of the time to continue working on your review sheet and your book.